Okay, in this video we're going to look at trigonometric integration. So first we do need to know our rules of trigonometric integration. It's a lot easier to know your integration rules if you know your derivative rules very, very well. So let's look at this. So this is asking us for the integral of sine. We've got a lot going on in here, but that's not a big deal. So basically, what is the integral of sine? Well, the way we need to think about this is, what can I take the derivative of that gives me sine? And so if you know your derivative rules very well, you know that the derivative of cosine of x is actually negative sine. Okay, notice there's no negative here, and so that negative is going to get transferred to our answer here. But if the derivative of cosine is negative sine, then the integral of sine is negative cosine. Remember, everything inside our trig always stays the same. And then just like the other integration you've learned, I need to divide by that number in front of x. So I'm going to divide by a, and I'm going to put plus c. Okay, so that would be the integral of this. Of sine ax plus b, the integral would be negative cosine ax plus b over a. Notice what was inside my trig never changed. Okay, so let's look at cosine. The integral of cosine, we're going to ask ourselves, what can I take the derivative of that gives me cosine? And so the derivative of sine is cosine. Therefore, the integral of cosine must be sine. And so I'm going to have sine of ax plus b. Again, I have to divide by the number in front of x here. So a on the bottom plus c. And you can do that same process with all of these. So this is the integral of secant squared. I'm going to ask myself, what can I take the derivative of that gives me secant squared? And if you know your derivatives, you know the derivative of tangent is secant squared. And so this is just tangent x. These are basic rules, but we know what to do when there's stuff inside. So the derivative of tangent is secant squared. So the integral of secant squared is tangent. Always what's inside your trig stays the same, divided by the number in front of x. And then I will have plus c. Okay, so again, if you know your derivative rules, this is very, very simple. Again, you're going to be asking yourself, what can I take the derivative of that gives me cosecant squared? And that is a cotangent, negative cotangent. So I'll write that one over here. So when I get the derivative of what is going to give me cosecant squared, and that's going to be cotangent, but actually the derivative of cotangent is negative cosecant squared, and so that's very similar to what we had here. And so this negative is going to be in our answer this time. So we're going to say negative cotangent of ax plus b over a, and then I have to put plus c for my constant out there. And so again, what can I take the derivative of that's going to give me secant tangent? Well, that's secant. So I'm going to have secant of ax plus b over a plus c. So the derivative of secant is secant x tangent x. So the integral of secant x tangent x is secant. And then here, the integral of cosecant, cotangent, would be cosecant ax plus b divided by a, but we do have to have a negative here. Because if I take the derivative of cosecant, I would get negative cosecant cotangent, and obviously you don't see a negative here, so we put the negative in the answer. So the negative here. So the integral of cosecant x cotangent x is negative cosecant. Okay, but now we have to be very, very careful not to get our signs wrong, our positives and negatives. So when we took derivatives, if we took the derivative of something that started with a c, so you can see that here, the derivative of cosine, we had a negative answer. And the derivative of cotangent, we had a negative answer. So anything we took the derivative of that we were taking the derivative and it started with a c, it was negative. But in this case, it's anything that we integrate that has a c starting with a c. So cosine, cotangent, cosecant, those are all going to have your negatives here. So you can't forget those, and you can't put the negative in the wrong spot. Okay, so let's look at some examples. Okay, very basic examples. This is the integral of sine of 2x. Again, you have to memorize your rules or ask yourself, what can I take the derivative of that gives me sine? And we know that that's a cosine, but there's a negative involved, so the integral of sine of 2x is going to be negative cosine 2x divided by 2, because we have to divide by what's in front of x, plus c. And I can write this as a negative 1/2. That might be easier if we're going to do some other things with it, but either way is fine. Okay, so that's your integral. Okay, and so this is the integral of cosine. Well, what can I take the derivative of to get cosine? The derivative of sine is cosine, so the integral of cosine is sine. And so I'm going to have sine. Everything inside of my trig stays the same, but I have to remember to divide by the number in front of x, which is 3, plus c. That's my integral. Okay, so it's just about knowing your rules. All right, so I want you to take a minute and I want you to try this problem. Okay, so this one was pretty basic. It's what can I take the derivative of that gives me secant squared? And that's tangent. The derivative of tangent is secant squared, so the integral of secant squared is just tangent x, because I didn't have anything else going on inside, and plus c. All right, take another minute and do this next one. Okay, this is the same as this last one, except we have more going on right here. So we know that the integral of secant squared is tangent, but we have a 5x inside, which means we have to remember to divide by the number in front of x. And we have to remember to put plus c for our constant. Okay? All right, take a minute and try this one. So on this one, we do have this 4 here that's out in the front, and if you really wanted to, I don't usually do this, but if you wanted to, you could write the 4 in front. I just want you to understand it's the same. And then you could actually integrate this part and tack your 4 on. So your 4 is just going to get multiplied, so 4 times. And then we ask ourselves, when I integrate sine, what do I get? So when I take a derivative of something, what gives me sine? And we know that there's a cosine involved there, but we have to be careful with our negative sign. So the integral of sine is actually negative cosine 4x divided by 4 plus c. And then this 4 was multiplied, and you can see that these two 4's are going to cancel out, and I'm just going to have negative cosine 4x plus c. Let's talk about how could I check this maybe for just a second if I wanted to. So on basic integrals, if I wanted to check this, I could actually derive. I could actually go backwards. So if I wanted to check this, I would ask myself, I have a negative 1 there, and I would ask myself, if I derive cosine, what do I get? Well, the derivative of cosine is negative sine 4x times 4. And so this double negative goes away, and that's positive, and I end up with a 4 sine 4x, which is exactly what I had here. So I know that my answer was correct. Okay, so just a way to check it with the basic integrals. Okay, so let's look at this one. Take a minute and try it. Okay, again, I'm taking an integral of cosine, and I have a 3 in front, so the 3 is going to get multiplied. The integral of cosine is going to be sine. Inside is going to stay the same, but in this case, guys, this is like a 1/4 here, so I'm going to be dividing by the number in front of x, which is 1/4, and then this does simplify. 3 divided by 1/4 is actually 12. And so I get 12 sine of x over 4 and then plus c. And again, you could check this the same way. You could take the derivative of this to see if you got what you started with up here. Okay? Okay, take another minute and try this problem. Okay, so this is cosecant squared, and I do have a 4 in front, so I'm going to have 4 times. And we got to ask ourselves, what can I take the derivative of that gives me cosecant squared? Well, we know that that is cotangent, but remember, when I integrate, if I have a c starting with my answer, then it's going to be negative. So I have negative cotangent of x. And since there's just an x inside, I'm technically dividing by 1. So this is my integral. I need to put plus c, and then 4 times that negative 1 there is going to be negative 4. So I would rewrite it like this. Okay? And again, try taking the derivative of this and make sure that you get back to what you started with. All right, last problem here. I want you to try this one. Okay, what can we take the derivative of that gives us secant x tangent x? And that's secant. So the integral of secant tangent is secant. Remember, what's inside your trig will stay the same, but then I have to divide by the number in front of x. And we don't really like to have fractions within fractions, so dividing by 1/3 is the same thing as multiplying by 3. So this would be the answer that we would have. And again, I could take the derivative to check to see that this was correct. Okay? All right, it's all about knowing your rules. You have to know your rules really, really well. Memorize them and you'll be fine. All right? Well, I will see you next class.